For the past several years, frontier AI development was fueled by venture capital and private speculation, but that era of experimentation is ending. As these models move into global enterprise deployment, the industry hits a physical threshold where the laws of infrastructure and accountability lock into the earth. This timeline tracks the evolution of that obsession. For most of this journey, the only metric that mattered was capability. Labs were evaluated almost exclusively on model performance and research breakthroughs, leading to the rapid growth of increasingly massive systems. But here, the trajectory breaks. The cost of training and running these systems is colliding with the reality of enterprise budgets. We are now entering an efficiency shift, where the focus moves from what a model can do to what it costs to do it. We have reached a point where capability is no longer the primary bottleneck. The new frontier, the only metric that will determine which of these organizations survive, is whether their intelligence can be delivered at a sustainable economic scale. Anthropic's decision to file for an initial public offering is the clearest signal of this transition. An IPO triggers a funding shift. It forces a transition from venture-backed growth into a business maturity phase, where the company is evaluated as a long-term infrastructure provider. Public investors operate differently than venture capitalists. They demand predictable revenue, operational discipline, and a clear pathway to profitability, factors that have largely been absent from the frontier AI landscape until now. This shift influences internal priorities. Labs can no longer focus solely on benchmarks. Success is now measured by enterprise adoption and operational excellence, proving not just that the models work, but that the business around them can scale sustainably. Public market entry effectively ends the era of AI as a research project. It is now expected to function as an accountable, foundational layer of the global economy. The race for dominance has evolved. It is no longer just a competition between software architectures. It is a massive, capital-intensive struggle for physical compute, energy, and networking capacity. Alphabet's $80 billion build-out focuses on securing massive GPU clusters and expanding data centers. This scaling creates critical dependencies on power and semiconductor chains, with demand growing so fast that Google recently engaged SpaceX to secure additional compute. This creates a structural dependency for the rest of the ecosystem. AI-native platforms are seeing such rapid growth, they require massive multi-year deals with these hyperscalers just to keep their systems online. Access to physical infrastructure is the primary strategic moat. Whoever controls the hardware, networking, and energy ultimately determines how AI is deployed globally. Traditional software costs are relatively static, but AI intelligence is a consumable resource. Every reasoning step and every long context analysis requires a direct expenditure of compute power. This creates a massive economic challenge when moving from simple chatbots to autonomous agent loops. While a single human prompt has a fixed cost, an agent working continuously to resolve a complex workflow triggers an exponential explosion in token consumption. Major enterprises are already hitting these limits. Uber was recently forced to implement strict spending caps after its employees reportedly exhausted the company's entire AI budget in only 4 months. To manage this, organizations are adopting model routing. They use smaller, specialized models for basic tasks and reserve premium, high-cost compute only for the most complex reasoning challenges. Unchecked AI adoption is a financial risk. To scale without compromising their margins, businesses must implement rigorous AI operations and governance to ensure every token consumed delivers measurable ROI. The crushing cost of cloud inference is forcing an architectural shift. We are moving away from centralized data centers toward a decentralized hybrid approach. NVIDIA's AI PCs facilitate this transition by pushing intelligence to the edge. This provides enterprise leverage to eliminate latency, slash infrastructure bills, and ensure sensitive data stays locally on the device, rather than relying on cloud-only computing. These foundation models are also expanding into physical world prediction. New AI-native weather startups are already outperforming traditional physics-based simulations, generating more accurate forecasts using a fraction of the power. The future of computing is a localized, hybrid execution layer. Intelligence will no longer live in a single cloud. It will be distributed across every device, balancing peak performance with economic reality. Software engineering is undergoing a phase transition. Anthropic recently revealed that up to 80% of its own production code is now being authored by its AI model, Claude. This staircase tracks the developer's changing role. We've moved from simple code assistance to AI as the primary codebase producer. Reaching the supervision-centric stage, the mandate changes. Developers no longer focus on syntax. Their value lies in systems architecture, verification, and governance. The most valuable engineering talent is no longer measured by how much code they write manually. It is measured by their ability to orchestrate and secure AI-generated systems at scale. These systems are moving into operational customer workflows. Apple's approval of Poke as an AI agent for business messaging signals that AI is moving beyond simple chat and into an execution layer where it can resolve requests and complete transactions autonomously. This comparison illustrates the escalating risk. While a chatbot operates in a controlled interaction, an agentic AI must navigate an open, adversarial environment where every web page or user input can become a manipulation vector. This autonomy introduces new enterprise attack surfaces. Security researchers recently demonstrated how AI-assisted support systems could be manipulated to bypass account recovery protocols, turning an efficiency tool into a vulnerability. The risk is significant. Anthropic found that its own browser agent could be hijacked in 31% of attack scenarios before safeguards could intervene, potentially leading to unauthorized actions and data leakage. This is why operational AI security is becoming a critical discipline. Highly capable agents require equally sophisticated control systems, granular permissions, runtime monitoring, and human-in-the-loop verification. The next decade of business transformation belongs not to those who can deploy the smartest models, but to those who can master the economics of inference and rigorously govern autonomous systems. Ultimately, success now depends on turning raw intelligence into a sustainable, accountable, and enduring layer of global infrastructure.